Welcome to this MarkLogic video tutorial from MarkLogic University. In this video, we will discuss how to search your database documents for geospatial information. In this tutorial, you will learn about geospatial vocabulary and how to easily construct simple and complex searches against your database documents. Let's first give a definition of the word geospatial. Here, the term geospatial is used to describe data related to a specific location on Earth. Not only does geospatial describe a location, but also the shape of that location. The location is identified by Earth coordinates and the shape by a specific geometry. The simplest geospatial data is a pair of coordinates, latitude and longitude, that forms a point. For example, the exact center of a city is a point used to compute distances between places. But geospatial data can include multiple points and form different regions. A line string representing a road or journey. A flat box or rectangle to define a region of interest. A circle marking an area of influence around a point at a given radius. A polygon showing a country boundary. And finally, a complex polygon, here a donut shape for South Africa boundary without Lesotho. And here's what geospatial data looks like. Let's have a look at a basic example with our simplest shape, the point. Here, a JSON document with a single point for the center of Paris. These are the coordinates returned by the Google Map API for Paris, France. Note that the document path to extract the coordinates value is location chords or /location/chords in XPath, which means that the geospatial data value is in the property chords of the ancestor location. Why is this important to us? A knowledge of the geospatial data layout will be important when creating the index to use for searching through our geospatial data values in queries. And here is a second example describing a region of type polygon that marks the rough boundary of France. Notice that the coordinates include multiple points and that the data layout is slightly different than the one in our first example. We will thus have to create a new geospatial index to search the /location/CTS region geospatial values. The geospatial functionality of MarkLogic enables your application users to search data with location information. There are two types of searches. One, you can search for points matching points or for points within a region. For example, find documents which describe universities located in Paris, or find documents describing universities located within 100 kilometers around the center of Paris. 2. You can search for regions against each other. For example, find information about regions that overlap a fire zone polygon, or find information regarding regions that intersect an aircraft path line string. To achieve this type of searches, MarkLogic supports several geospatial coordinate systems. An important point is that MarkLogic always preserves the precision of geospatial data in your documents. Data is loaded as it appears in its original form. For example, if you ingest documents containing double precision coordinate values, those values retain full precision. However, the precision of values in a geospatial index is determined by the configuration of the index. Therefore, you might have double precision values in your documents, but single precision values in the corresponding geospatial index. Because precision and accuracy are often wrongly used interchangeably, let's remind ourselves that accuracy measures how close a result is to the truth, and precision measures how close repetitive results are to each other. Now let us discuss the indexes. Even though our geospatial data is in our documents, We would get very long-running queries if we had to open and look up each document while searching for coordinates information. To make geospatial searches fast, MarkLogic has specific geospatial indexes which can be configured either manually through the administration console or via script. There are two types of geospatial indexes: point indexes and region indexes. Let's first have a look at geospatial point indexes. Whether your documents are XML or JSON, you should be able to find the right index for your data layout. If you're trying to decide which geospatial point indexes to use, consider the following. If your data layout looks like this, you can set up an element index. If it looks like this, you can set up an element child index. Use an element pair index for this layout and an element attribute pair index for this one. Or you can simply address the coordinates using an XPath expression. The other type of geospatial index is used for region data layout and is named Geospatial Region Index. Region layout is standard. You can simply use a region path index to address the coordinates of your regions. In the next slide, we will look at a configured region path index for the path/location/CTS region. To configure a geospatial region path index, you will need to add the following configuration to your database. Path expression specifies the path to the data in the document layout. Coordinate system specifies the name of the coordinate system used for the geospatial data. Units indicates which unit of measure to use for distances. GeoHash precision specifies the precision of geohashes used in a region index. Invalid values specifies whether the server should allow or reject the insertion of documents with invalid values. To follow along with the next hands-on, you will need to install MarkLogic 9 and download a workspace from github.com/marklogicuniversity/geospatial. Once you have downloaded and installed MarkLogic 9, downloaded and imported the workspace in Query Console, you're ready to create some documents with geospatial data and search them. Let's get hands-on. As a reminder, you can download MarkLogic 9 from developer.marklogic.com by clicking the Download Now button. If you're not sure which version of the software you're running, open a new browser window and go to the Administration Console. Check the software version on the top left-hand side. You should be running MarkLogic 9.03.1 or later. The workspace that we're about to work with is on the GitHub MarkLogic University page, along with a readme.md file that contains step-by-step instructions that we will follow along during this hands-on. Once we have downloaded the workspace and imported it in Query Console, we're ready to execute the few tabs. The first tab will insert the documents in the database. The second tab will create geospatial indexes. The third tab will search for points, matching points, or points within region. And finally, we'll search for regions that have a relationship to other regions. Let's do it. In the first tab, we're inserting some documents, JSON documents, containing properties that hold coordinate values for points, location/coords, and properties, CTS region, that hold values for regions like polygons, location/CTS region. If we run this query, we are going to be inserting in our database 5 documents. Notice the documents database need to be selected. Next, we will create the geospatial region using an endpoint here from our REST API. 2 geospatial indexes need to be created, one for our point values and one for our region values. Notice the different type of indexes: geospatial path index for points and geospatial region path index for regions. Let's run this. And let's check that our indexes were inserted correctly. documents database contains now a geospatial path index with the path expression slash location slash chords, and also a geospatial region index for the path expression slash location slash CTS region. Now we're ready to do some search. Search for points. In the first search, we are trying to find documents that contain points that match our input criteria here, Paris. And we're using the CTS path geospatial query, and we'll be looking within this index path expression for values containing points that match Paris. The second search is using the CTS path geospatial query, also looking in the same index, but now the criteria is not a point but a region. We're looking for points within our index that are within Europe. And if we run this, we should get 1 point matching Paris, and that's the document containing the Paris city coordinates, and 2 documents having points that are within Europe, and those are the documents that contain a city that is within Europe. Next tab, we're going to execute another search. Now we'll be looking for regions that have a relationship with another region. Our region input criteria is Western Europe. And this is the last argument here. So let's have a look at the CTS search. We're going to use here a function called CTS Geospatial Region Search. And we're going to say that the regions that we're interested in are within our index for the path expression slash location slash CTS region. So we're looking for region values within that region path index. And the relationship that we're looking for is within. So we're looking for regions in our documents that are within our input criteria, Western Europe. And if we run this, we should get 2 documents back, France and Spain. Once we have run these queries and feel more comfortable with how geospatial search works, we're ready to play with the geospatial application. Let's follow this link and download it. Back in the README file, we're at step 5. We want to go to this GitHub page and clone the repository to a local directory. Once this is done, we simply need to run the setup.sh from a command prompt or terminal window, which will install an app server and a database for us. Now, we will change something to the app server configuration. We will just connect it to our documents database. Let's do it. From this page, we would like to download or clone the repository. Once that's done, you can run the setup.sh from a command prompt or terminal window. Once that's done, we can go and have a look at our app servers and see that there is one at port 3333 with name Geo Region Search Server, for which we want to change the database so that our documents database is selected. Don't forget to click OK. At this point, if you go to localhost :333, you should be seeing a map. We're not ready to use the application yet. We need to do some changes. If you don't see Europe, but you see San Francisco zoomed instead, there's something that we need to change in the application code and to search our documents database for the /location/CTS region path, we need to do some changes to the search function of the application. Please follow steps 9 and 10, and don't forget to save the files in order to customize the application. Then go back to localhost 333 and play with the application. So here, what we can do is draw a rectangle over Europe, Western Europe. Select the within relation and search. We should find 2 polygons. Those polygons are defined in our documents database. So if you would like to reset the application here, you can just click F5 and that will erase any shape you have, or you can draw another shape and it will replace the previous shape. Now let's test a different shape, a line string. So we want to use the left click of your mouse to create a starting point. Then with your mouse right click that you want to hold down, you draw a line. Then you can left click to create another point. Then right click, you draw and continue this string of lines, so on and so forth. Then we want to know if we have any regions in our database that, to finish the line string here, sorry, just click the left mouse click again. All right. Any region that intersect with this line string, let's search, and we do. In this tutorial, you learned what geospatial data is and how to search it in MarkLogic using specific geospatial indexes. As a next step, make sure you go out and get MarkLogic and access all the examples of this tutorial through the MarkLogic University GitHub site. And for your additional training needs, make sure to check out marklogic.com/training, where you can learn about all our different courses and learning resources that are available to you for free.